In this video, we're going to be discussing how we factor trinomials when there's a coefficient in front of our x squared. So as we factor these polynomials, we're going to use the same x method that we did before. In the previous video, we talked about how I would factor something that might look like this. Now, x squared plus x minus 6. Notice how the coefficient here is 1. We're going to discuss what are some methods to address when that coefficient isn't 1. I'm using that same method. So as a review here with this first method, I'm going to use my x method, and I'm going to say I want two numbers that multiply to get my c, or my -6, and add to get the coefficient for my b. In this case, it's a 1. So then I list out those factors of -6, and I look at -1, 6, -2, 3, -3, 2, and -6, 1. And I notice -2 plus 3 equals 1. So here I've got my -2, here I've got my 3, and as I write out that factored form, I get x minus 2 and x plus 3. Factored. Now, this worked great when a equals 1. When we have something where a doesn't equal 1, what we have to do is we have to adjust our x a little bit. Really, our x is, in the previous video, we talked about it looking like this, and then we have our p and our q. What we're going to do now with that a is that a actually affects what's happening here, and it's going to affect our c. So how I'm going to set up my new x is I'm actually going to do a times c. So we're going to multiply the size of our c by a, and then I want to find what factors of that add to give me my b. And as I find those factors we like to call p and q. But because I multiplied everything a times, those factors are a times too large. So I need to divide those factors by a. And then as I divide those factors by a, these fractions will simplify, and I'll end up getting my factored form of this polynomial. So let's take a look at a couple of examples of how this might work. So this first one, factor x squared minus 5x minus 7. Now remember, we're going to multiply. This 2 is a, our -5 is our b, and this -7 is our c. So we're going to factor this right here. So we're going to multiply our a and our c. And I have a 2 times a -7, which gives me a -14. And then I have a -5. So I want to know what factors of -14 add to a -5. So I have a -1 and a 14, a -2 and a 7, a -7 and 2, and a -14 and 1. -7 and 2 are what add to get -5. So I have my -7 and my 2. Now, this -7 and 2 are enlarged or multiplied by that 2. So I want to reduce their size. I want to divide them by that multiple. So I'm going to divide both sides by 2. And notice how this 2 over 2 simplifies down to a 1, but this -7/2 doesn't. So as I'm writing my factored form, what I'm going to do is I'm going to simplify my fraction here. And I want to look, whatever number here is on the bottom is what I'm going to write multiplied by x. So in this first case, I have a 1 times x plus whatever number is on top. Okay, so then I have a +1. Now in this other case, we want to multiply x by whatever's on the bottom. So I have a 2x. Yellow is hard to see. I have a 2x, and then this -7 is what I'm going to add to the edge, -7. Now notice I can multiply this out and get that same solution here. And the biggest thing that we need to look for is 2 and this 1. If I multiply these first two terms together, am I going to get this 2x squared? Well, 2x times 1x is 2x squared. So we're golden. If for some reason those two numbers don't multiply to that, then we might need to reduce our fractions, or we might need to, maybe we need to factor our polynomial before we did this, factor out that greatest common factor. So this is what it's going to end up looking like, is we have something in front of our x times that, and the bottom number of our fraction is always going to be what we multiply times x. The top is what we add or subtract. So let's take a look at another example here. 4x squared plus 13x plus 3. Now remember, when we talked about factoring, the first thing is finding a greatest common factor if there is one. Is there a common factor between 4, 13, and 3? No, because 13 is prime, right? So the only factors of 13 are 1 in itself. So this is the most factored form of this polynomial before we factor it down into two binomials. So now I'm going to multiply 4 times 3, and I get 12 for the top of my x, 13 for the bottom, and I want to know what numbers multiply to 12 and add to 13. So as I look through that, I have 1 and 12, I have 2 and 6, I have 3 and 4, and look, 1 plus 12 equals 13. So I have 1 and 12. But remember, this has been scaled by a factor of 4. So I need to reduce it by a factor of 4. So I have to divide both of these numbers by 4. And what do I end up getting? Well, this simplifies down to a 3. And that's a 3 over 1. So as I'm writing my factored form, what I end up getting is the number on the bottom here times x. So I have a 4x plus a 1. And then this 3, or a 1x plus 3. And for the sake of this problem, I'm going to leave my 1 off because that's more common what we do in math. So we're going to do it that way. Now I want you to take a second, pause the video, and set up this next one. Now before you do, notice there are no factors between 3, -7, and 2. So we can't factor anything out first. So therefore, we're going to start right into our x method here. So go ahead, pause the video, and work on that x method. When you finish, unpause the video. Okay, hopefully you've had the chance to work through this problem on your own. If you have, go ahead and look here. So I multiplied my 3 times my 2 to figure out what to put in the top of my x, and I get a 6. Then I put that b in the bottom, and I want to figure out what numbers multiply to get 6 and add to get -7. And those are -1 and -6. But remember, I scaled this. I increased my factors by 3. So to get these factors broken down, I have to divide them by 3. So as I divide those by 3, I have a -1 divided by 3 and a -6 divided by 3. And -6 divided by 3 does simplify to a -2. So as I'm writing out these solutions here, I remember I'm going to put my bottom number times x and my top number on the other side. If it comes out to be an integer of some kind, like a -2, all that I need to do is pull it in here, and there's no coefficient on that x, and that's how it's going to work out. Now, we've looked at some problems that look like this. I want to take a look at this problem as our last example here. Factor 5x squared plus 15x plus 10. Now, remember those rules for factoring. The very first thing we have to do is look for a greatest common factor. And we've kind of talked about it and haven't seen any. But in this example here, there is a greatest common factor. There is a number that goes into 5, 15, and 10, and that number is 5. So before I can even set up my x, what I need to do is rewrite this as 5 times x squared plus 3x plus 2. And as I write it like this, then I'm going to be able to factor this out. And remember, our next step is to count our terms. With 3 terms, that means I'm going to do my x method. So here we go. Let's look into that x method, but remember, we're only going to do it with this polynomial here. And notice that as I factored out that 5, we no longer have an a in front of our x here. So I don't have to worry about multiplying and dividing that. So what I'm going to do is set up my x factor here. I've got to multiply back to 2. I've got to add to 3. Well, the only factors of 2 are 1 and 2. So this is going to be a 1 and a 2. We did not have an a, so I don't have to divide those. So this is going to factor out this polynomial here into x plus 1 times x plus 2. But when we fully factor this, what has to end up happening is we actually have to include that 5 there. So the factored form of this 5x squared plus 15x plus 10 is actually going to be 5 times x plus 1 times x plus 2. That's fully factored out. We have to factor out that greatest common factor before we go into the other parts. Otherwise, our methods aren't always going to work. And we can see that every time. So then when you look at examples like this and we can't do it, we can hop right in. But remember, anytime there's something that we can factor out, even if it's just a 5, factor it out before you do your x method. And that's how we would do this x method with a coefficient in front of that x squared. First, we're going to check to see if there's a greatest common factor. If there is, we're going to factor it out like we did here and then do our x method. If there is not, then we're going to hop right into doing our x method. And remember, the x method that we're doing in this problem is going to be a times c we need something that multiplies to a times c and adds to b, and whatever those things are, we have to remember to divide them by a and simplify those fractions. And that is how we're going to factor when we have a trinomial with a coefficient in front of a, or in front of our x squared.